Hello! I chose my boyfriend to participate in the decimals teaching task. First, I asked him if he knew any rules for adding decimals. He said you have to line up the decimals before adding. He said the same thing for subtraction, remembering to put the decimal point in the answer. For multiplication, he said to count the number of digits after the decimal and put the same number of digits behind the decimal in the product. And for division, he said to multiply the divisor by as many tens as necessary until you get a whole number. I then had him perform a problem for addition, subtraction, multiplication, and division. For addition, it was 3.121 plus 1.733. For subtraction, it was 15.312 minus 6.12. For multiplication, it was 4.76 times 7.32. And for division, it was 12.6 divided by 0.2. I let him solve these however he chose to, and they were all solved by traditional algorithms. I chose to do this to ensure he knew the rules for decimals before showing him the why. For addition, I chose the base 10 blocks because he said he was a visual learner. For subtraction, I chose the place value chart to show how you can regroup before subtracting the smaller number. For multiplication, I chose the area model to put an emphasis on place values. And for division, I chose to write the problem's numbers as fractions to show how each number represents a place value. For the base 10 blocks with addition, I started off by showing him 3.121 plus 1.733. The cube was equal to a whole, so you add from right to left just as you would in a traditional algorithm. So 1 plus 3 dots is equal to 4 dots. 2 plus 3 longs is equal to 5 longs. 7 flats plus 1 flat is equal to 8 flats. And 3 cubes plus 1 cube is equal to 4 cubes. So the answer was 4.854. This is the same as saying 4 and 854 thousandths. Then I had him solve 7.48 plus 1.33. I chose this problem because it involves the need to regroup. He got 11 longs and circled 10 of them. This allowed him to add another flat and be left with 1 long. The answer is then 8.81, which is the same as saying 8 and 81 hundredths. I used the place value chart for subtraction. I chose 15.33 minus 6.125. This is a semi-concrete representation. In this problem, you regroup before you subtract. You take 10 away from the hundredths place in 15.33 and add that 10 to the thousandths place. You also take 10 away from the tens place and give it to the ones place in the subtraction process. 10 minus 5 is equal to 5, 2 minus 2 is equal to 0, 3 minus 1 is equal to 2, and 15 minus 6 is equal to 9. Your answer is then 9.205, which is the same as saying 9 and 205 thousandths. I used the area model for my multiplication problem of 3.23 times 7.34. I liked this method because I could show him how you could leave the products as fractions and then add the fractions. You can write them as decimals at the end as you are adding them all up in the products. This method breaks down the problem into individual place values. 7 times 3 is equal to 21. 7 times 2 tenths is equal to 1.4. 7 times 3 100ths is equal to 0.21. 0.3 times 3 is equal to 0.9. 0.3 times 0.2 is equal to 0.06. 0.3 times 0.03 is equal to 0.009. 0.04 times 3 is equal to 0.12. 0.04 times 0.2 is equal to 0.008, and 0.04 times 0.03 is equal to 0.0012. Once you add all these products up, you get 23.7082. He commented that this would show how addition is implemented into multiplication. So I am reading the numbers as 0.06 or 0.009. It is important to read them to the student as 6 100ths, 21 100ths, 9 thousandths. My division problem, I had him write it out as fractions. I think this is very similar to the traditional algorithm. I use 12 divided by 16 hundredths. This is the same thing as saying 12 divided by 0.16. You then multiply 12 by 100 over 16, and you get 1,200 over 16, and your answer is then 75. I think the base 10 blocks went the best. It was easy for him to draw it out and visualize the addition problem. It helped to visually see how you regroup a group of 10 to the next place value. He struggled the most with the place value chart. He didn't like the regrouping of the bigger number before you do the subtracting. If I was to do something different, I would show him another division method. Although writing the number out as fractions seems simple, I think it is too similar to the traditional algorithm. I would teach the repeated subtraction first if I was a teacher. I learned how important it is to be very familiar with each method. Each child may learn differently and benefit from different methods of solving decimal problems. Thank you.